Hello friends, welcome to this session. In the today's session, we will start a new unit. The unit name is torsion, and the very first topic we are going to start, that is a very basic concept of the torsion. So let us start with the first slide. The very first slide is the shaft, because in this particular unit we are going to use one of the object which is subjected to torsion. That object is the shaft. Shaft may be of a circular cross section and maybe a non-circular cross section, but in this our topic we will use the object which is a circular cross section. First of all, the definition of the shaft. The shaft are usually cylindrical in section, solid or hollow. They are made up of mild steel, alloy steel and copper alloys. So in this one of the small figure, you can see there is a shaft is there. There is a axis line is there for the shaft, and this particular shaft is of a circular cross section. It may be a hollow or it may be a solid, and this particular shaft may be made by mild steel, maybe alloy steel and maybe a copper alloys. So this particular shaft, which is of a circular cross section and in the longitudinal direction, that shaft may be subjected to different types of the loading. So these are the different loadings are there that shaft is subjected. So that first load is a torsional load. You can see there is a rotational movement is there to this end of the shaft, and this will produce the torsion in the two opposite direction. So there is a torsional load is also that shaft is subjected. Also there is a bending load that shaft will take, axial load, combination of above three. So it may be a individually torsional load, bending load, axial load, and also there is a combination of the different loads are also that shaft has taking. So shafts are designed on the basis of strength and rigidity. So basically for the designing of the shaft, that two main important criteria are there. One is a strength parameter and another is a rigidity parameter. So following values are usually adopted for the shaft design. So basically we are using at the time of designing that different stresses value. So below are the two stresses value are given. One is a sigma, which is a direct stress or axial stress in any direction. So that direct stress is value for the design, it is taken as 112 Newton per mm square or MPa. So it is a maximum permissible tensile or for the compressive stress. So this sigma, this value is taken for the designing of any shaft, and this tau is nothing but the shear stress. So shear stress value is taken for the design is 56 Newton per mm square, and this value is called as permissible, maximum permissible stress. So let us start the concept of torsion. First of all, the torsion, it is nothing but the twisting it is a rotational movement. It is given to the both end of the shaft. So basically, as I told you that we are using the shaft here, which is of a circular cross section. It may be a solid or it may be a hollow material. So here, for understanding of this basic concept, let us see this particular figure. So this particular figure is this circular shaft is there, and at the other end it is a free, but in this one end there is a bearing. This particular shaft is fixed at the bearing. So that's why there are rotational movements are applied to both of these ends. So in this particular end there is a clockwise movement is applied, and in this particular fixed end bearing, at the bearing there is a anti-clockwise movement is. So there are two unequal opposite moments are acting onto this particular shaft. That's why there is a torsional moment and there is a torque is applied. So in the both of this direction there is a moments are applied. Because of that, shaft will twist. So there is a twisting is happened into this particular shaft. That's why this particular twisting, and there is a torsional moment on both of these ends, that it is called as torsion. So let us see, if we are rotating this particular shaft in clockwise direction, at this particular end there is a clockwise direction, bearing will try to rotate in opposite direction. So this bearing will rotate in opposite direction. That's why the torsional movements is created, and that shaft is twisted. So that's why this particular phenomenon it is called as a torsion. And also one more example is there for the understanding of the torsion is that if you take the pen in both of these arms, that if pen rotates in your palm in opposite direction. So one is at the clockwise and another is anti-clockwise at direction. At that moment also there is a pen will be in twist. So there is a twisting of the pen, it is happened, and this twisting of the pen is called as a torsion. So very simple example, only take the pen in both of these hands, and one is at the clockwise and another is anti-clockwise, and there is a twist is created, and the twisting is the torsion. So torsion is also called as a twisting or the torsion movement. So there are movements are applied in two opposite direction. So that twisting, it is a twisting of an object caused by a movement acting about longitudinal direction. So it is a twisting of an object caused by movement. It is twisting, it is happened because of the movements are created or movements are produced in the two opposite direction about the longitudinal direction. So torsion is also called as torque. So that torque we can determine by using this formula. So tangential force into radius. So you can see in this particular cross sectional circular cross section is there, which has a radius r, and there is a torsional movement or torque is applied. It is in suppose clockwise direction, and there is a tangential force is there. You can see this Ft is a tangential force. If you multiply this tangential force to this radius, you will produce a torque, and you can calculate the torque. So this tangential force multiplied by radius, this will produce the movement or a rotation. So that rotation or that rotational movement, it is called as torque. So this Ft into r, this Ft means this force, tangential force, it's in Newton, and this r radius is in mm. So that's why it will produce the rotational movement, and that rotational moment it is called as a torque, and that unit of that torque is Newton into mm. So force multiplied by radius. Next you can see this twisting or torsional movement. Torque is a movement that causes twisting along the length of the bar. So basically we understood that torque is a movement on both of these ends that causes a twisting. After application of the movement on both this direction, the twisting is taken place into the length of the bar, and this twist is also called as a torsional deformation. So because of the twisting, there is a deformation may takes place onto the bar or onto the shaft. That deformation is a torsional deformation. For circular shaft, torque, which is also called as a torsional movement, rotates each cross section related to nearby cross section. So torsion is a twisting of a rod or beam as a result of applied torque. If you applied the torque on both of the direction, both of these ends, so it will create the it will create the twisting of that rod, and the twisting of that rod is called as a torsion. So you can see in this particular figure there is a shaft is there. This is the axis. So this particular figure is for the before deformation. So deformation not taking place here. So but after deformation you can see there are changes. So if you are see onto the surface of this shaft, there is a circles. There are circles are there after loading that remains circular. So that is this is a before deformation, this is after deformation. After applying the load, that circle remains the circular in cross section. But longitudinal lines, you can see this. These are the longitudinal lines. There are changes or deformation taken place onto the longitudinal direction. So that becomes a twisted. So after application of the load or after applying the torsional movement, that longitudinal lines become twisting, and this radial line remains straight. So that radial or that circles remain straight after the loading or after the deformation take place into the shaft. So this torque moment around axis line. So that torque is nothing but the movement around the axis line. So this you can see on both of these ends, this torque is applied. This is in clockwise direction and this is in anti-clockwise direction. So movement around the axis line, that it's called as a torsional movement, and torsion is also called as a twisting. So if you applied the torque, when you applied the torque, so there is a twisting is taken place. Twisting is happened onto the surface. So there are changes are there. This is figure of the after deformation and this is before deformation. So there is a changes are only onto the longitudinal lines. Next assumptions for those. So for the designing of the torsion, for the designing of the shaft, so some of the assumptions are there for the torsion. So that assumptions are related to the material and related to the properties of the material which is used for the structure design. So let us first take that first assumption is that the material of the shaft is uniform or homogeneous and isotropic. So whatever the material is used, which we have to take place the torsion or twisting, so that material should be, that shaft material should be of uniform throughout, and it is homogeneous and isotropic, means properties and the materials are same in all the three directions and at every point, at every place in the material. Second, the shaft circular in section remains circular after loading. So as we have seen in the last slide, that whatever the circular sections are there, that remains circular after loading. So before loading and after loading, circular section remain same. The plane section of a shaft normal to its axis before loading remains plane after the torques have been applied. Whenever the before applying the torque and after applying the torque, that plane section which is normal to the axis, which is, remains plane before torque and after the torque also. So that is also one of the assumptions we have to take. Twist along the length of shaft is uniform throughout. So whatever the twist is there, that twist after the application of the torque or torsional movement on both of these ends, that twist are same throughout the length of shaft. That you remember this assumption. Distance between any two normal cross section remains same after the torque applied. So that is also similar to the above, that distance between any two normal cross sections. So before deformation and after deformation, that figure is important here. So with this figure you can easily understand or easily formulate that this particular assumption. Distance between any two normal cross section remains same after the torque applied. So all dimension of the shaft before twist remains unchanged after twist. So what are the dimensions are there for the shaft which are same, which are similar before the twist or before the application of the torque, that unchanged, or after the twist also, that are same. So maximum shear stress due to torque does not exceed its elastic limit value. So whatever the maximum shear stress due to torque has been produced, that shear stress, it will not exceed its elastic limit value. So that's it for this particular session. Thank you very much.